This season was supposed to start with answers. Instead, Red Bull may have just dropped the biggest bombshell of the entire Formula One grid. Because after the first race in Australia, many people inside the paddock believed the RB22 had serious problems. Reliability questions. Tire degradation. A brand new Red Bull Ford power unit that looked powerful, but dangerously unpredictable. But now something shocking has emerged. Right before the Chinese Grand Prix weekend, Red Bull quietly revealed a set of radical adjustments to the RB22. Changes so precise, so strategically targeted, that rival engineers immediately started paying attention. Not because they were large upgrades, but because of what those upgrades reveal about the real potential of this car. Shanghai is one of the most brutal circuits in Formula One. One of the longest straights on the entire calendar. A first corner that tortures front tires for several seconds. And a layout that exposes every weakness in cooling, aerodynamics, and hybrid energy deployment. If a car has a flaw, Shanghai will expose it. Which is exactly why Red Bull chose this race to introduce these changes. And here is the terrifying part for the rest of the grid. If the RB22 solves the problems we saw in Australia, even partially, the car we saw at the season opener might not represent its true performance at all. It might have been only a fraction of what this machine can really do. Which raises a question that suddenly becomes impossible to ignore. Did Red Bull just unlock the real potential of the RB22 right before one of the most demanding races on the calendar? Because what engineers are starting to notice inside the Red Bull garage could completely change the direction of the championship. So before we break down the upgrades, the hidden technical changes, and the real reason Red Bull rushed these adjustments before China, make sure you subscribe to the channel. Because the story behind the RB22 is only just beginning. Right after the Australian Grand Prix, something unusual happened inside the Red Bull garage. The team did not react like a squad that had just finished the opening race of a championship. There was no sense of calm analysis. Instead, the engineering group immediately began an intense internal investigation. Because the data coming from the RB22 told two completely different stories. On one side, the numbers looked extremely promising. During several clean laps, Max Verstappen extracted pace from the car that placed Red Bull right in the fight with the fastest teams on the grid. The aerodynamic load looked strong, the cornering stability appeared competitive, and the car showed moments of the efficiency that Red Bull has been famous for during the last dominant era. But when the race entered longer stints, something started to change. The rear tires began overheating earlier than the simulations predicted. Not dramatically, not in a way that would immediately destroy a race, but enough to make the engineers uncomfortable. Because in modern Formula One, tire temperature is everything. If the rear tires cross their thermal limit even slightly, traction disappears. When traction disappears, drivers must correct the car on corner exit. And every correction increases the temperature even more. It becomes a spiral. A small imbalance becomes a performance problem. A performance problem becomes a strategic problem. And eventually that problem decides the outcome of a race. But tire degradation was only part of the concern. The real shock came from the power unit. When the Red Bull Ford engine failed in spectacular fashion during the race in Australia, the moment immediately raised serious questions across the paddock. This is not just another engine update. The Red Bull Ford project represents a completely new power unit philosophy. A new hybrid energy system, a new internal combustion architecture, and a cooling strategy that pushes the limits of packaging inside the RB22 chassis. Everything inside this car is extremely compact. The side pods are tightly sculpted. The airflow channels around the engine cover are incredibly narrow. And the entire design philosophy is built around maximizing aerodynamic efficiency while keeping the power unit as tightly integrated as possible. That approach creates enormous performance potential. But it also creates risk. Because when you compress components that aggressively, heat becomes the enemy. Temperatures rise faster. Cooling margins become smaller. And the engine must operate inside a very narrow thermal window. Australia revealed that this window might be even tighter than Red Bull initially expected. And that discovery immediately changed the team's priorities before the next race. Because the next stop on the calendar was not just any circuit. It was Shanghai. One of the most technically demanding tracks for engines, tires, and aerodynamic balance. The Chinese circuit forces cars into long sustained corners where front tires carry heavy load for several seconds. Then, only moments later, the cars launch onto one of the longest straights in Formula One, where engines remain at full throttle and hybrid systems deploy maximum energy. This combination punishes every weakness a car might have. Cooling, drag, energy deployment, tire temperature control. If a car has even a small flaw in one of these areas, Shanghai exposes it immediately. And that is exactly why Red Bull arrived at the Chinese Grand Prix with something much more important than a traditional upgrade package. They arrived with answers they were desperately trying to find. Because what the engineers began to suspect after Australia was something far more complex than a simple reliability problem. They began to suspect that the RB22 might be operating on an extremely narrow aerodynamic balance window. A window where the car produces incredible performance when everything aligns perfectly, but becomes unpredictable the moment the balance shifts even slightly. And that suspicion led Red Bull engineers to focus on one very specific part of the car before arriving in China. A part of the RB22 that most fans never notice. But that could completely change how the entire car behaves over a race distance. And that critical area of the RB22 sits underneath the car, where almost nobody can see it. The floor. In modern Formula One, the floor is not just another aerodynamic surface. It is the heart of the entire performance concept. Nearly all of the car's downforce now comes from the airflow traveling under the chassis, accelerating through complex channels before expanding inside the diffuser at the rear. When that airflow remains stable, the car feels glued to the track. When it becomes unstable, the entire balance of the car begins to shift. And after Australia, Red Bull engineers started to suspect that the RB22 floor was operating extremely close to its aerodynamic limit. During Verstappen's fastest laps in Melbourne, the car produced massive ground effect load. In fact, the downforce levels in certain corners were even higher than what the wind tunnel simulations had predicted. At first, that sounds like fantastic news. More downforce usually means more grip. But the data revealed something much more complicated. When the floor generated that extra load, the aerodynamic balance of the car shifted slightly toward the rear. It was a very small shift, almost invisible to the eye. But for a Formula One driver, that small change is enormous. Because when the rear of the car gains extra load, the front tires suddenly need to work harder to keep the car rotating through the middle of a corner. That is exactly when drivers begin making tiny steering corrections. And every one of those corrections increases tire temperature. Now imagine that happening during a full race stint. Lap after lap, corner after corner. The rear tires slowly accumulate heat until they finally cross their thermal limit. And once that happens, the driver begins fighting the car instead of controlling it. This is exactly the pattern Red Bull saw in the data from Australia. Which is why the team quietly began modifying the most sensitive aerodynamic surfaces around the floor before arriving in China. These modifications were not dramatic. You will not see them easily on television cameras. But inside the world of Formula One engineering, they are extremely significant. The edges of the floor were subtly reshaped to control airflow sensitivity. Small geometric refinements were introduced to stabilize how air enters the Venturi tunnels beneath the car. And the interaction between the floor and the rear suspension airflow was carefully adjusted. All of these changes aim at one single objective: stability. Not maximum downforce. Not maximum speed. Stability. Because if the airflow under the RB22 remains stable during long corners, the aerodynamic balance stops shifting toward the rear. If the balance stops shifting, the driver no longer needs those tiny steering corrections. And if those corrections disappear, the rear tires remain inside their optimal temperature window. That is the chain reaction Red Bull is trying to fix. But the story does not end there. Because the floor is only one part of the equation. The RB22 is also one of the cars most dependent on the new active aerodynamic systems introduced under the 2026 regulations. These systems allow the car to switch between two completely different aerodynamic configurations. One configuration maximizes downforce for corners. The other dramatically reduces drag on long straights. And Shanghai contains one of the longest straights in the entire championship. Which means this transformation happens at one of the most critical moments of the lap. Drivers exit the long spiral opening corner, begin accelerating through the early sector, and then launch onto that massive back straight where engines deploy maximum power. At that moment, the RB22 must transform from a cornering machine into a low-drag missile. If the transition happens smoothly, the car becomes incredibly efficient. But if the transition slightly disturbs the aerodynamic balance, the rear tires suddenly receive a surge of load right when the driver is applying maximum throttle. That is exactly when overheating begins. So before arriving in Shanghai, Red Bull engineers also began recalibrating how the RB22 manages these active aerodynamic transitions. The timing of the system, the energy deployment that accompanies the transition, and the airflow stability as the car shifts from high downforce to low drag mode. All of it had to be refined. Because the engineers inside Red Bull began to realize something extremely important. The RB22 might not have a fundamental weakness. It might simply be operating on an extremely narrow performance window. A window where everything works perfectly when the balance is correct, but where even the smallest disturbance can push the car outside its optimal zone. And that realization leads to a question that suddenly becomes very uncomfortable for the rest of the grid. What happens if Red Bull finds the exact setup that keeps the RB22 inside that window for an entire race distance? Because if they do, the car that struggled with tire degradation in Australia might suddenly reveal a level of performance that the rest of the paddock has not yet seen. But there is one more layer to this story, and it might be the most important one of all. Because while everyone focused on the aerodynamics, the tires, and the reliability scare from Australia, something else inside the RB22 was quietly evolving. The way the car delivers its power. The Red Bull Ford power unit is not just a mechanical engine connected to a battery. Under the 2026 regulations, the hybrid system plays a much larger role than in previous eras of Formula One. Electric energy deployment is now a central performance factor. How the battery charges. How the motor generator deploys that energy. And exactly when that energy is released during acceleration. All of it can completely change how a car behaves on corner exit. And that is exactly where Red Bull engineers began focusing their attention before the Chinese Grand Prix. Because when they analyzed the Melbourne telemetry, they noticed something unusual during the moments when the RB22 exited slow corners. The hybrid system was delivering power very aggressively. In terms of raw acceleration, that sounds like a major advantage. But there was a hidden consequence. That sudden surge of torque placed enormous stress on the rear tires. Imagine the driver exiting a slow corner, the car switching aerodynamic modes, the engine delivering full combustion power, and the hybrid system suddenly releasing a massive amount of electrical energy at the exact same moment. All that force travels through the rear tires. And when the tires are already close to their thermal limit, that energy spike becomes the final trigger for overheating. This is why Red Bull engineers quietly adjusted the hybrid deployment maps before arriving in Shanghai. Instead of releasing the electrical energy in a sudden burst, the system now delivers power more progressively as the car accelerates onto long straights. It is a small change. But in Formula One, small changes can have massive consequences. A smoother power delivery means less stress on the rear tires. Less stress means more consistent traction. More consistent traction means the driver can apply throttle earlier without overheating the rubber. And suddenly the entire performance window of the car becomes easier to control. This adjustment also has another strategic benefit. Shanghai's massive back straight is one of the most important overtaking zones in the championship. Cars accelerate for several seconds before reaching the heavy braking zone at the end of the straight. If the RB22 can deploy its hybrid energy more efficiently across that entire distance, it gains a crucial advantage. Not just in top speed,